This conference will now be recorded.
Thanks, everyone. My name is Larry Lachman, and I'm here to present my project, which is an automated article recommendation system for a marketing and sales force. So my target audience is basically what I just said, a marketing and sales force. I wrote this, it's an automated NLP-based recommendation system specifically for the restaurant or hospitality industry, but directly related to casual dining. So when we generate custom tailored article recommendations, the hope is A, we're going to drive more engagement, B, we're going to lead to a better connection between the marketing and sales force and the prospective customers, and C, ultimately we're going to generate more revenue for the organization. So every marketing and sales person who's ever worked in the industry has the challenge of how do they sound relevant to customers. Everybody faces this, and there's always some apprehension about having a conversation with customers. And to make it a positive connection, the goal of this project is really to recommend an article, a current article, that would be salient to a customer's business needs. And if chosen appropriately, it's going to be a good icebreaker. It's going to help them start a conversation with a customer, and it's going to actually show that the person, the salesperson or the marketing person, is really engaged and understanding what the customer's business is all about. And hopefully by going that extra mile, they're going to secure the business, if not now, certainly for in the future. I used a lot of different technologies to put my project together. My data source, I curated my own data source. It comes from FSR magazine. FSR stands for Full Service Restaurant. I used Beautiful Soup, which is a Python library for scraping the web. I used an NLP, a natural language processing library called Spacey, for parsing all the articles. And it's a really powerful program that really efficiently handles massive amounts of text data. And I have a lot to show you about Spacey. For interactive widgets and creating lots and lots of different dashboard type controls, I used iPie widgets and another program called Plotly. Plotly is an open source package that allows you to have really, really powerful publication quality graphs without having to write CSS or JavaScript. I used word cloud to render the most prominent and germane words to different articles. And then I also used Jupyter Notebook extensions. It's called NB extensions. You can search for it, and it's going to help me navigate. I have a lot of code, and help me navigate my Jupyter Notebook and show you where everything is, including all the interactive widgets. So this is my timeline. It was a pretty ambitious timeline. I started back on the 18th of July when I chose this project, and I established benchmarks. I designed my initial approach. I had some great conversations with Sravan and Vish. And by August 8th, I had my first iteration done of my web scraper class. I was able to scrape the website for fsrmagazine.com and able to actually ingest my curated data and perform exploratory data analysis on it. By the 22nd of August, I integrated Spacey and TF-IDF with my solution. I was doing more exploratory data analysis. I spent a lot of time doing data cleaning on the data that I was scraping. And I finalized my data model, my final data representation. And my first approach, I would skim the articles, and I would label them as either a 0 or 1. 0, they don't concern casual dining. 1, they do concern casual dining. So my first and very simplistic machine learning model that I implemented was logistic regression. And I designed, by near the end of August, I designed my NLP pipeline. So we got to mid-September, and by then I had implemented a clustering model. I have a lot to tell you about what I discovered with logistic regression. But I implemented a k-means clustering model. I did a lot of feature engineering. I started with principal component analysis, and I was able to visualize the clusters that I was generating, and I was able to visualize the silhouette and inertia scores. I'm going to be talking about all these different terms in just a few minutes. At that point, I was able to label the clusters and engineer categorical data from those clusters. And then I also extended my solution by implementing a grid search CV implementation for cross validations. Then at really the beginning of this past week, I was almost done with this model, but I've had a very, very busy last couple of weeks since the September 12th. I engineered then a classifier for K nearest neighbors. I did more feature engineering, and I also added another dimensionality reduction algorithm called latent semantic analysis, implemented that. And I started building all the interactive widgets, the IPy widgets and Plotly, added the Jupyter extensions, and added word cloud. And just this past weekend, I finished the predictions and the pickling of the model. So that was my timeline. This is my architectural design. So I start up here in the top left corner with the articles in the FSR magazine. I've scraped roughly 100 articles since I started working on this project. I think the actual number right now is about 94, 95 articles. I ingest the data. I'm doing a lot of pre-processing. I mentioned the data cleaning and the exploratory data analysis. I'm turning those words into vectors, numeric representations of the words, so using TF-IDF. I'm going to explain that and define that in a few minutes. And I'm taking an unsupervised machine learning approach initially, because I want to explain this. I thought I was going to have labeled data. I told everybody I was labeling things 0 and 1, but I wanted to let initially the machine learning model group these, cluster these, and let me know how the machine learning model interpreted these articles. So I initially took this unsupervised learning approach and started implementing, along with the k-means, the first dimensionality reduction technique, which is principal component analysis, PCA. Once I got to implementing k-means, I did my silhouette and inertia analysis. There's a methodology called elbow optimization method that uses inertia to figure out how to optimize the number of clusters that you're going to be using. And then I loaded the model, and I observed, once I created all these different clusters and different numbers of clusters and different levels of dimension reduction through PCA, I was able to observe what the clustering mechanism decided how to group all these different articles that I was loading. And once I did that, I did the data transformation here, where I labeled the clusters manually based on how the clusters had been formed by machine learning. And I engineered categorical data, and I used that data as input into the K nearest neighbors classifier for supervised learning. Both of these then produced the ability to recommend articles to the end user. So this was the pipeline that I designed back in August, and I'm here to tell you that I actually implemented the entire pipeline. Yes. All right, so a little bit of terminology before I get into all the technical stuff. To lematize is basically take the articles and reduce them down to their original roots. That way, then words with tenses and different ways of saying words, they're reduced from 3 or 4 different types of words to 1. Tokenizations, breaking text into different pieces, and of course ignoring the white space and punctuation. I mentioned earlier how for machine learning we need to be able to represent words as vectors of numbers. And then TF-IDF is just a way of normalizing our words such that we know how important the words are, not only in the document, which in this case is an article that we're looking at, but how that is important relative to the other articles as well. And that's what a TF-IDF score gives us. And it helps tell us the importance of all the different words. So I mentioned earlier that clustering is an unsupervised methodology, and you typically use this when you have unlabeled data. And the reason I went down this approach is because as I was labeling everything zeros and ones, and you'll see my my null accuracy later, it was almost 80%. There were all these articles, almost 80% of the articles concerned casual dining. And I originally thought I was also going to evaluate the sentiment of the articles too, but it was like 98% or more of the articles were positive. Rarely did you get a negative article. So my initial hypothesis didn't prove to be valuable. I wasn't going to generate something that was going to be of real value. So the clustering method gave me an opportunity to take the unlabeled, unstructured data and let the machine interpret it and tell me what it had. So the clustering algorithm partitions the data into K clusters. Now, if they were labeled, that would be done easily, but the machine does it for me. And the goal here is to let the K-means algorithm divide the set into disjoint clusters that are described by their cluster centroids. And the cluster centroids are really important because that's where the scoring comes in on how you measure the distance of the individual articles from that center for scoring for both the silhouette and for the inertia. And so a couple of definitions are up there as well about the silhouette analysis, and I'm going to be showing you visually later how important this was to me, because I was really surprised when I did my silhouette and inertia analysis of the results. I didn't know what to expect, and I didn't have high hopes going into it, but I was really, really pleasantly surprised. So silhouette analysis basically is you want that number to be positive. That's the first thing. If it's zero or negative, then the articles have been assigned to the wrong cluster. That's the main message here. And the inertia tells you just how dense or coherent the cluster is. You don't want your articles spread way out where they overlap other clusters. You really want tight-knit clusters that says, yeah, this article really belongs in this cluster, and that's what inertia measures. So initially I found something that's I'm quite familiar with now, called the curse of dimensionality. When you're doing natural language processing on text, you can create a vocabulary of anywhere from a few hundred to thousands of words in your vocabulary. In my case, I have over 6,200 words in the vocabulary of these 94 articles. And most of what I learned in creating and doing this project is that every sentence is a vector of these 6,200 words, and because of that, it's a very sparse matrix of vectors. It's a sparse matrix because you have mostly zeros here. Out of 6,200, every sentence is just going to be a very small subset of that entire vocabulary. And machine learning models cannot deal with such a large number of features. I tried as an experiment, and I did run the machine learning models, the classifiers, without doing dimension reductionality, and my percent of accuracy was roughly 50 some odd percent. It was terrible. It was really, really bad. So you have to choose a dimension reductionality algorithm, a technique, to reduce it from 6,200 dimensions to something that's more manageable. And what I chose was a principal component analysis and latent semantic analysis. And I was very curious to see how different they would do in terms of the actual results that they produced. And so I'm excited to show you those results. So we get to the point where we have clusters, and the articles in each cluster, when I got to the point where I was ready now to create the recommendation system, what I did was I ranked the articles based on whether they're trending on the website. There's a way to detect that. And so I keep track of which articles are trending. Do they concern casual dining? That was my own manual label. And how recent their publication date is. And that's how I created the list of the articles that I recommended to the user. All right, who's ready for a demo?
Me.
All right, me too.
He's been waiting.
Yeah. All right. So over on the left, this is my Jupyter notebook, and you can see the NB extensions that I've added gives me the ability to navigate this pretty big notebook easily. And so that's what I'm going to use here to show you things. Instead, I'm not going to I'm going to try to minimize the actual amount of code that I show you. But initially, I'm going to go ahead and I'm going to load this CSV file that again, I curate myself. And by the way, of my 94 articles, what I did was I took 75% of them, and they're in this CSV file called fsrarticles.csv. And I took 25% of those articles and I stuck them in a separate test data set that I'm not going to train on, and that when I'm ready to run my classifiers on, they'll run on the test data that's never been seen. So that was the strategy there. All right, so I performed some exploratory data analysis on the data frame. Basically, I wanted to check if there's any null values. Of course, there's not. There was initially. I did a lot of data cleaning here, so I had total control over how clean the data set was. So I had no null values. I'm looking at all my data types here, and I didn't have any duplicated values. I don't now. I actually did. I had a lot of duplicated URLs that I was scraping off the website, but I cleaned that up. So I come down here and I initialize Spacey, and what's really interesting here, I'm going to show you the exploratory data analysis I did once I implemented Spacey. I want to show you how powerful the Python package is for natural language processing. For the first thing that I did was I just wanted to look at the articles. So here, as I said, I took 75% of the 94 articles. I have 71 articles that are in my data set, and their average, the mean length is just under 1,000 words. Right here. And then I did a distribution of the actual article lengths. Now the average is roughly 1,000 words, so you're going to see a heavy distribution over here. And you can see there were 30 articles that were basically 500 words, 19 articles that were roughly 1,000. And then then the numbers decrease here to the point that I get some outliers here. There's a 3,000 word article, 4,000, and then all the way over here there's a 6,000 word article. Then I did some analysis on the titles. So I created an interactive widget here where I just said, okay, I did a whole bunch of analysis in this cell on the 71 different titles, and I created all these different, and again, I'm using Spacey for all this. So I said, first of all, what are the most common words in the 71 titles? You can see that the word restaurant popped up 19 times, America 6 times, and then the number 50 4 times. And these are the 20 most common words. But I can also go back, again, I'm just analyzing the titles. What are all the noun phrases in all the titles? And it's just kind of interesting just to see how Spacey parsed all this information.
So the nouns are automatically getting pulled from the sentenizer.
That's correct. And I wrote the initial sentenizer that comes with Spacey wasn't sufficient for what I needed, so I actually wrote a custom one, and I built it into the NLP pipeline. So not a little too far. Those are the noun phrases. I can choose what are all the verbs that are in the titles, and then last but not least, this is actually interesting. I can choose what are the named entities in the titles, and not only does it show me the named entities, it also labels them. This is an organization. This was a date. This was money. Here's a person. It says, well, it was actually Breakout Brand. That's kind of funny. Probably was because capitalized. But you can see how Spacey decided to label each of these named entities. So got this one right. Bob Evans is a person.
Royal Wedding is an organization. Okay.
Yeah, so it's interesting the way Spacey parsed everything. So I had a little bit of fun setting this up just to show the power of what the package can do for you. So I went down, I computed my null accuracy, and as I mentioned earlier, I'm almost at 88%. That 77.5% of the articles concern casual dining. So because of that, what I decided was, and I had run a logistic regression model and I wasn't pleased with it, I'll show it to you later. I kept it in here, but the logistic regression model was not even better than computing null accuracy. In fact, I won't get too far ahead of myself, but it was a disappointment. So here's my unsupervised machine learning approach. I've already presented all the text I have here in the slides defining everything, the approach that I took. So I came down here, and I want to just say one thing about principal component analysis just before I show you the clusters. I drew a very simplistic diagram to explain what it does to reduce the dimensions from over 6,200 words in my vocabulary to the different numbers that I chose were 15, 10, 6, or 2. And I gave an example here, and you'll see on the different axes here, I drew 3 X's. One is if we, and each axis represents an article. So we have 2 articles. Now, if one article has the word training in it, and the other article doesn't, then the X falls here on the X axis because the inner product between the 2 articles is going to be just 1, 0. Now, same thing if we have an article over here that has the word safety, but it does not have the word training, then it's going to be 0, 1. But if they both have, if they both have the word safety and training in them, then the inner product is non-zero, and we form an eigenvector here that helps us reduce. This eigenvector represents both words. That's a real simplistic way of showing this, but it does show you that how we take these different concepts and map it down to a lower dimensional space. All right. So the first thing we do, I've run k-means on all my articles, and I came up with, this is my first visualization. Oh, I got ahead of myself, sorry. There's one more thing to show you. Right below here. Okay. This is one of the things that I wanted to show you that really was a really pleasant surprise to me. So I visualized all the different clusters and their silhouette scores and their inertia scores. And I'm not going to talk about every individual one here because there's a ton of these graphs here. But what I am going to show you is I'm going to scroll down to the one that surprised me the most. I originally thought, well, I don't need, because I thought I was only going to do maybe 2 or 3 clusters of articles. I don't need a lot of clusters, but I ran this all the way up to 6 clusters. And this turned out to be the most interesting one. So I just want to describe what you're looking at, and then I'm going to show you the silhouette scores and the inertia scores, and so that you know what motivated me to choose this configuration going forward for k-means. So over here, the red line, the red dashed line, represents the average silhouette score. Remember I said earlier it needs to be positive. Otherwise, it tells you you've put the articles into the wrong clusters. So my average silhouette score here is 0.223. And in each of the different 6 clusters, you can see that I've got 18 in this one, I've got 8 in this one, 23 in this one, 17, I've got 1 over here. And each of the clusters is numbered 0 through 5. And then I visually represent, and I drew where the centroid is for each cluster on the right side. And each of the points representing an article is colored in a different color. So I didn't choose this configuration because of these 2. I wanted to see how it looked. But when I came down here, this was what the big surprise was just how significant the silhouette score was to 6 clusters and how small the inertia score was. Remember, the silhouette score says we're farther away from the other centroids of the other clusters, and the inertia score is telling us, yeah, they're coherent. The articles that are in this cluster belong in this cluster. So ultimately, after analyzing all the different configurations, and I did PCA components, just to remind you, of 15, 10, 6, and 2, and then I did clusters 2 through 6. I ultimately chose this one with 6 clusters and 10 components. So coming down here, I built this interactive widget Again, this is a combination of IPI widgets and Plotly. And I can change any of the configurations here. I'm going to change them. I'm going to show you how dynamic this interactive graph is. But what you're looking at right now is you're looking at the PCA is the reduction, dimensionality reduction algorithm. I can also choose LSA, and I'm going to show that to you as well. I'm choosing currently 10 features. I've gone again from 6,200, over 6,200 features down to 10, and 6 clusters. And the clusters are colored here, so you can see what they look like. And what's interesting about this graph is I can hover over any of these. I'll show you the title of the article, how these got clustered. So this is pretty cool. This is what helped me determine how to label these, the clusters, by seeing which articles were assigned to each cluster. I can also, if I really want to focus on a certain cluster, I can zoom in. I can zoom in some more, because sometimes some of the points, the articles will overlap. So if you want to examine this more, I can double click, take me back. I can also, if I really want to focus on just one cluster, I can go over here and just start disabling these. So now you're only looking at cluster 0. So this is a really powerful tool. And the reason I wanted to let you know about this is because, again, I'm using a Plotly interactive graph. And if I had to write JavaScript to write this, this could have taken me days. But I did this in just a few lines of code. So now that you've seen what it looks like with 6 clusters, 10 components, I'm using principal component analysis. Let's see what it looks like if I just choose the dimension reductionality algorithm to latent semantic analysis. And this is what the clusters look like. I still get 6 clusters because I haven't changed that. I still get 10 features. But
so those 2 in yellow, do they still point to your Cheesecake Factory?
Well, in this case, I think they actually do. But the colors definitely might change. In this case, though, these are still the anomalies.
So it does not matter whether you use PC or LSA. You still landed on those same 2.
The clustering is different, though.
Sure.
Because look, take a look at, this is the one thing that concerned me about this particular configuration, is look at the cluster 4, which is the red one. It's spread way out, and unfortunately, the thing that concerned me about cluster 4 is there's a tremendous amount of overlap with cluster 4 with all the other clusters. So it's not as coherent. The inertia score is going to be a lot higher for this cluster. Whereas if I go back to PCA, definitely didn't have the big overlap in the clusters like I did with LSA. If I go all the way down to 2 components, or I'm sorry, 2 features, 2 components, then I get very, very tight coherent clusters, both with LSA and PCA. So what's really cool about this is that you can now visualize these dimension reductionality techniques with a scatter graph. That's what I'm using here.
Can you talk about the strategy for naming your clusters?
I sure can, yeah. So let's go back. Let's talk about the strategy for naming the clusters. I'm going to go ahead and put this back to 10. And I still have 6 clusters. So what I did was I looked at these clusters and I looked at the concepts that are being assigned here. And what I noticed was, and we'll take cluster 5 as a first example. There's 3 articles in cluster 5, and all are concerned about workforce training. So I labeled this workforce training. If I come over here, this is now cluster 2 in green. The articles that were assigned to cluster green, to cluster 2, really concerned strategy. What was the strategy that these restaurants are implementing? For cluster 1, I believe this was, I can show you one because I don't have them all memorized, but what I chose was, this looks like brand marketing. And then for here,
You can pull it.
yeah, I'm going to show you all the cluster. Well, what I eventually did, and I have them just to kind of cheat a little bit, I'll come down to the recommendation. Here we go. So when there we go. Right, the code where I did that, I manually labeled these, but when I'm using PCA, my clusters are named workforce training, names and partnerships, anomalies, strategy, rankings and numbers, and brand marketing. And they're not exactly the same when I do LSA. LSA does a different mapping, but the concepts were the same. So, okay. So this is the scatter graph that demonstrated and visually represented how the articles are being assigned. And I'm now to the actual interactive system. So when we come up, here's my different categories that I've labeled for the 6 clusters. And you can choose whatever you want. In this, let's choose workforce training. As I mentioned earlier, there were 3 articles in workforce training. All 3 come up here, and I labeled their publication date and whether they're trending. So in this case, they're not. But these are hyperlinks. So when I display them, I can right-click and say open up in a new window. And lo and behold, there we go. How Dave & Buster's modernized its workforce. So I close that. I allow then the user to configure, not only can they choose then the topic that they're interested in, but they can also increase this number. So right now, what I'm choosing is 5, but in this case there were only 3 articles that I could show. But if I choose a category where there's definitely more than 5, and I know for a fact if I go to brand marketing, so there's 17 articles right here. There's 17 articles in this topic, so I can increase this number. So right now I'm showing the user the top 5, and one of these 5 articles is trending, but I can increase the number to 10. Now I've got 10 articles. If I go up to 15, I can now have 15 articles. Now, one feature that I do too to help the sales and marketing staff, they could look at this and they can see the titles and they can guess obviously what it's about. But I used another technique to rank all the words in the article. So here we have 5 articles, and I'm going to scroll down and show you what I did. I visualized the most important words in those 5 articles using word cloud. So what I did was I created a bag of words, 1,849 words from those 5 articles, and I have an algorithm that goes through and says what were the most important words in these articles, and this is the words that it chose. And if I go back up here and choose a different, let's go back to let's take strategy. So there's my 5 articles. One of my articles is trending, the Texas Roadhouse article, and I can again go down here and see what word cloud thought was the most important words in those 5 articles. All right. I also created another interactive widget that allows me to just search. Let's just say that I want to see what were the most recent, or maybe a list of articles published between 2 certain dates. Here, 19 articles were published. This is the first 2 set of candidates that I have between September 1st and September 22nd. But I can go in here and I can choose, let's go back to July, let's go back to July 1st. So 71 articles were published. I can scroll down here. You can see again which ones are trending. Like I said earlier, I rank them. When I go to the different clusters, I rank them as according to whether they're trending, whether they concern casual dining, and then by their publication date. And that's how they're listed based on that ranking. So any of these articles that were published, I can go under. These are all hyperlinks, and I can click on them and go read the article. So those were the interactive widgets that I built. Once I finish this, I've labeled my data frame, which I I show right here. I create this column here for cluster that I went ahead and assigned, so I can see the different cluster numbers that were assigned by the machine learning model. And then I also created the column there where I've labeled the data with the cluster topic. With this input data, I now implemented my supervised machine learning models. So the first one I implemented was K-neighbors classifier. And what was interesting about this, I went and I ran this through a range of 1 to 25 neighbors to evaluate it. And when I did, I got the best value was 83% accuracy for neighbors equal 1. I drew a little plot there to show what happened to the accuracy. You have the 83 up here for 1%. You can see as you increase the numbers, my accuracy went way, way down. So interestingly, then I took that classifier, the K-neighbors classifier, and I went ahead and I used it with a grid search cross-validator. And when I did that, my mean score using cross-validation went all the way up, because what the grid search did was it chose the best parameters for the K-neighbors classifier. My accuracy went from 83% to 93%. It did really, really well. So that was interesting. And it gave me back right here. It said, here's your best parameters that you should use with this classifier. Because the only thing I said earlier was just the number of neighbors, but this came back and said, use these arguments, you'll get the best result. It'll be the most accurate. And you can see I have a running table here that shows me everything that I've run. Here's the K-mean scores. You can see all the silhouette and inertia scores. At the very bottom are my K-neighbors classifier scores. And you can see whether I'm running a principal component analysis or latent semantic analysis. That's my dimensionality reduction algorithm. Then I ran K-neighbors classifier. Earlier I ran it with PCA, with the grid search CV, and the second algorithm I ran it with LSA, and my accuracy improved from 93% to almost 96%. So I'm really nearing almost 100% accuracy now. I've gotten all the way. I went from my initial blind run of K-neighbors classifier of 83%. I'm all the way up now to almost 96%. And you can again see where I've kept track of my different results. Well, this was the final step. Was I kept this around just to show it to you. This was my initial simplistic logistic regression model that I initially thought was going to be what I was going to use and go forward and demonstrate to everybody. But when I ran logistic regression, you might remember that my null accuracy was 77.4%, and the mean cross-validation score was 77.5%. It was not any better. And in fact, when I displayed the confusion matrix, the logistic regression guessed all ones. That's what it did. It didn't guess a single zero. So I was actually pretty surprised and disappointed. The last step, I pickled the model, I saved it to disk and reloaded it. And then once I reloaded it, this is where I loaded the CSV file containing the roughly 25% of the articles for just testing purposes. And I did a couple test predictions here. Like here were 2 articles. I just went out and grabbed and said, what are they? And it came back and said both of these articles belong to cluster 0 brand marketing. And then I ran it on the entire data set. And what you can see the different titles. Again, these were not articles that the machine learning models were trained on. I'd never seen these before. And it went through and predicted whether they were, you can see I've got a strategy here, some brand marketing, ranking and numbers, and so on and so forth.
What do you think? Were they right?
Most of them, they were right. It made a few errors. I went back and I looked at some of the articles. I said, yeah, I think this belongs in a different cluster, but for the most part, they were right. So for the future, I definitely want to enhance the user experience. I think I could, there was another product that I evaluated when I was learning Plotly. Plotly also makes another product called Dash for creating dashboards. And if I'd had more time, I would have actually created a really slick looking dashboard. I'm pretty pleased with the interactive widgets that I did create using the Plotly graphs. But in the future, I can create a much more better user experience by having a clear dashboard where all those different widgets are centralized. I'd also like to reverse engineer the eigenvectors to the words and the concepts that they represent. I think that would be something really valuable. And I think, look, any company that has a sales force, a marketing sales force, which is pretty much just about any company that exists in the world, this could be very useful for us. So I think that, different industries, financial, banking, digital dentistry, oil and gas, HR recruiting, I'm just listing a few, they could all benefit from an application like this to help engage with customers and be more relevant in those engagements. And also, even though this is ready today, this is ready for use today, what I've built, this could be deployed into the Azure cloud. And I'm looking at, if I were to do all this, I think productization would take roughly 6 to 8 weeks. And that is the end of my presentation.
Questions for him? C++ or Python?
Python, absolutely. I don't have to mess with pointers and memory management
Anymore.
Yeah, it's nice. It's nice. It's a very, very powerful language. There's a big learning curve initially. It's a paradigm shift is what it really is. But once you cross that threshold, yeah, I really like programming in Python a lot.
Management or engineering?
We'll see what opportunities await me, but definitely, it'll be technical no matter what. Whatever I do, that's for sure.
Last month, how was it? The last couple of days?
I've gotten like 12 hours of sleep since Wednesday, but it was a lot of work to complete this, and I felt really really motivated and really engaged in what I was doing. So I was happy, I was excited to do it. I felt really good about finishing this. The last mile was tough, but it was good.
Good job.
Thanks.